Alright, this is the second set of cards, geology. Remember that the purpose of this video is twofold. Number one, to be able to see the movements, and number two, to understand kind of the reasoning behind each of the words. If you don't understand the reasoning behind them, then you'll find it much harder to memorize, and also what's the point? Because the whole thing is supposed to be able to help you understand the words a little bit better. So let's get started. Rotation. So remember from the T's in rotation that's supposed to remind you of turn. And so you've got, you're supposed to stick your hands up and tilted like the poles, and you turn on the axis in a day. The reason that it's talking about turning on the axis means that it's not just like turning like this. The Earth is actually tilted, so it's kind of turning at a tilt. The axis itself causes seasons, but because of the axis, sorry about the dog, because of the axis, the rotation is also just kind of tilted. Don't let that throw you off when you see rotating on its axis. It's not talking about season. Rotation is turns on axis in a day, so you're causing day and night and shadows and things like that. Next, revolving. So you need to find something to revolve around. Remember, you can think this like revolver, like go somewhere and return back to it if you speak Spanish, or you can think of driving a Volvo if you don't. But you actually need to go around an object, like I'm going around this, chair right now. And so you say goes through all the seasons in a year as you revolve around another object. Axis, that's the tilted poles cause seasons, right? Because if it was just up and down, that means that as the Earth went around the sun, there wouldn't be any difference if you were over here or you were over here. But when the Earth is at a tilt, right now the southern half of the Earth would be getting more sun because it's more directly faced towards the sun. And then half a year later, the northern side would be facing towards the sun. And so it's the actual tilt that makes the seasons happen, as opposed to just having the same exact kind of weather all throughout the entire year. Time of day. So you've got dawn in the east and dusk in the west. Dusk is like sunset, basically, but sometimes they call it dusk, and so we included that to make sure you knew that vocabulary word as well. So you should be pointing to the east, pointing directly overhead in the middle because the sun is going overhead at midday, and then to the west at the end. Weather. So this one is what's happening outside. This is the sign language symbol for weather, which is just two W's that are kind of falling down, I guess like rain. Climate. So this means compare. I guess you're like comparing the two sides of your hands. It's kind of like all the single ladies, I guess, but it's compare 30 years of weather. All right, evaporation. So evaporation, you've got solar energy, so you got your sun up here, and then this is supposed to be the ocean or whatever, liquid to gas. Just did that one. Condensation. So condensation is happening when you get things like, actually this glass right here has a little bit of condensation on it, and that's not from inside the glass, that's because this was ice water, and so the glass was cold. So condensation happens when it gets cold, and you say gas to drops of liquid, right? And you're making that cloud, showing that that's what condensation most commonly is, right? The actual clouds. All right, precipitation. So precipitation is where the drops in the clouds are too heavy and can't be held up anymore, and they fall down. So drops too heavy, fall. Types of precipitation. I probably should have made snow go first on this card instead of sleet, but you've got rain, hail, because those are like the bigger chunks of ice coming down with more force. Snow is kind of like a snowflake slowly falling down, and sleet is like a mixture between rain and snow. So you got rain over here and snow over here. So rain, hail, snow, and sleet. Again, for things like this, the order doesn't matter. So if you say like hail, snow, sleet, rain, that's fine. The order doesn't matter. Also, if you change like the phrase a little bit, but you don't change the meaning, that's also fine. You know, you don't need to freak out about little details like that. Accumulation is a combination of two cards, right? So you have runoff and groundwater. Now each of those is its own card. So again, that's runoff and groundwater. Runoff is water sliding down the land, and groundwater, this is supposed to be the ground, is water sinking deep under land. So retain, usually this is talking about soils retaining water, but retain means to keep. So for example, when teachers retain a student, that means that they keep them in the same grade level. So retain means to keep. So if a soil retains a lot of water, it's keeping a lot of water, not letting the water go through. Loam is good soil. It's like, if you went to Home Depot and bought soil, that's the kind of soil you would see. Weathering, so you take two large rocks, and when you weather them, they break into pieces. So you start with two large rocks, and its rocks break apart. All right, next, erosion. So erosion and deposition are kind of the opposites, right? Erosion is wind, water, ice take land away, and deposition is wind, water, ice leave land behind. Sediment is movable pieces of land. You're not going to be able to actually move boulders with a river or with the wind, and so it needs to be first weathered down, right? So the weathering is the rocks breaking apart. They broke apart into sediments, which are small movable pieces of land. My dog is complaining. All right, canyon. So here you're showing the actual hole that the river is eroding. The river is digging into the land, right? So it's river erodes land away. And it shouldn't be like a U-shaped valley like that or something like that from a glacier. This should be a very steep valley, like a canyon, like in the tray tables with the sand and the clay that we did. Delta, so the sediment from the canyon, and it's in the river, so you're showing the river here, but canyon sediment makes new land. This is supposed to be the beach. Over here is the ocean. So the canyon sediment is coming, and then when it gets to the ocean is when it slows down, and it deposits all that new land here. That new land, the deposition, is a delta. And it's where the river meets the ocean. Sand dune, so wind deposits sand. You're just showing the sand building up because the sand dune is like a hill or mountain out of sand. Glacial valley, so you start with just a valley between two mountains, and it's ice bulldozes mountain valley. So you start as a V, and it turns into a U shape. Volcanic eruption, lava cools into new land. It's pretty obvious, it's just an eruption. Landslide. So this is kind of like runoff, except instead you're showing mud instead of water. So you got like the little trickling down right here. So landslides happen when there's a whole lot of water on the side of a hill, and it gets so saturated full of water that the mud starts to just slide down the hill, and it can bury like whole villages even. So landslide is flood makes mud slide. Earthquake. So tectonic plates rub, shake, and split layers of land, and you're showing the actual, these are supposed to be the big huge tectonic plates, the pieces of the Earth's crust rubbing against each other so that you can feel them kind of shake. A tsunami, so an earthquake, and that's right, the sign for earthquake, makes a huge wave in the ocean. Sedimentary rock, so you have sediments deposit in layers. Sedimentary rock formation. So this is a combination of the three cards after it. So first, or I guess deposition is from before, but first you have deposition, cementation, and remember that's like cementing the pieces of sediment together, right? So deposition, which is when water, ice leave land behind, cementation, and compaction, which is like the pressure. So all of those is what it takes to make the sedimentary rocks. First, you actually need the sediment to get deposited. Then the sediments kind of get glued together into one piece. So you have all these pieces of sediment, and they get glued together into one piece. And then after that, they're smushed, and so those thick layers get smushed down into thin, smaller layers. Those are the three we just went over. Fossil. So this is evidence buried in sedimentary rock. So this is supposed to be like a claw, like some evidence of some animal with a claw. And it's buried in sedimentary rocks. And here you're showing the layers, right, which are the key thing that you need to remember about how sedimentary rocks are formed, because it's depositing in layers, right? So a fossil is evidence buried in sedimentary rock. Fossil fuels, right? So each one of these shows like kind of how we get each one of these fossil fuels. So coal is the solid version. We have to actually like mine it out of the land. And so this is supposed to be like a pickaxe to mine the coal out of the land. And then it's oil and natural gas, because for oil and natural gas we drill down to get them. Please don't confuse charcoal with coal, right? Charcoal is just made from trees and plant materials. It's like a biofuel. It's from today's plants and animals. Coal is much more compact. It's been compacted just like the sedimentary rock. It's a lot more powerful, and so that's an actual fossil fuel. So the kind that you buy at HEB is charcoal, not actual coal. Fossil fuel formation. So this is talking about how fossil fuels formed, right? And so you have organisms and energy, and that's what this is supposed to be. Organisms, energy, trapped under sedimentary rocks. Just like fossil was evidence trapped under sedimentary rock, now this is organisms, energy, trapped under sedimentary rock. Now because it has all that energy inside, at the end we show it like blow up, because that's what fossil fuels do, right? So organisms, energy, trapped under sedimentary rocks. Generator. So remember, generator was like the hand crank thing that we had in class. And so when you have a magnet and a coil, and either the coil or magnet is spinning around, that's what makes the electrical charge. So a generator is mechanical energy spins to make electricity. Now each one of these is going to talk about the different ways that you make the electricity, right? So you got hydroelectric energy, and so you've got the water that's flowing over the turbine, right, as it goes through a dam, right? So here in the dam you have that turbine, and when the water turns, or when the water falls and goes over the turbine, it turns it kind of just like a water wheel, right, except it's connected to a generator. So hydroelectric energy is water turns the turbine. I guess you can see it better this way. Water turns the turbine. Geothermal energy, right? So you're sticking down the pipes into the Earth's crust where you're close to a volcano or volcanic activity, so that when you stick the tubes of water down in the Earth's crust, it heats up, maybe boils, rises, and then it turns the turbine. So it's Earth, and it's just supposed to be like a circle for the Earth. So Earth heats water and turns the turbine. Wind energy, wind moves the turbine. So you just blow on it, boom, that's wind, right? And that's exactly how basic a wind turbine is. Solar energy is not made with a turbine. And so instead you show like a solar panel here, and then you show the sun just shining on the solar panel, right? And so its panels make electricity with solar energy. Turbine, so the turbine is the ones that are involved in all the other ones. So you got hydroelectric, you've got wind, you've got geothermal, and all of these are using a turbine to spin the generator. So a turbine is the fan that turns to spin the generator, and this is just the symbol for generator, right? And so the fan that turns to spin the generator. That's it. We don't do nuclear energy this year because they took it out of our list. So I would strongly recommend going over this video until you can understand the meaning behind the movements and the phrases for each of these words. If you still don't get it, talk to Mr. Kenny so that he can explain it to you, or talk to someone that has already gotten their green note about science vocabulary. Because if you don't understand it and you don't understand the movements, you're not going to be able to pass, and you're not going to be able to memorize this. And honestly, you're just going to waste a whole bunch of time getting frustrated. So remember to only study 8 cards at a time before you move on, and also understand what it is that you're doing. If you're saying a phrase and you don't understand what it means, that means it's going to take you a really long time to learn it. And if you're doing a movement without really understanding why you're doing it, then it's also going to take you forever to memorize.